Assalamu alaikum. My name is Shahryar, and in today's video we will study the introduction to digital filter. So first of all we will see basically what are the basic reasons for what we design the digital filter. So there are two basic reasons. Main reason, the first one is separation, and the second one is restoration. So what does separation mean? So sometimes when our signal have some interference with the noise or other materials, so we want to remove that noise or other interference, so we use the digital filter to remove that noise or interference. And the second one is restoration, and sometimes similarly our signal is some part of our signal is removed or destroyed, so we want to recover that our signal. So to recover that signal we actually use the digital filter. So the common in DSP is here the both input and output are in time domain. So every linear filter has three responses. The first one is impulse response, and the second one is step response, and the third one is frequency response. So the most common one is the impulse response. So when impulse response is used in a filter design, then the designer call us special name, which is the filter kernel recursion. This is the special name which designer named it. So suppose we have a signal system which having the impulse response is this one. This is the impulse response, and here this is the amplitude of that system. So whenever we want to see this system into frequency response, then we see in this way. This is the frequency response. So when we integrate our impulse response, then we will get the step response, which is this one. This is the step response of our above impulse response signal. And similarly, when we integrate the frequency response, then we get the following result. This is the frequency response. So these are the some examples of our digital filter design. If we want to convert our results into dB or decibels, then we know we have a formula 10 log 10 P2 by P1, where P2 is the high power and P2 is the low power. Similarly, if we have amplitudes, then in amplitude, here we just multiply with 20 the remaining, and log 10 A2 over A1. This is the high amplitude and this is the low amplitude. Now we'll see the difference between slow step response and fast step response. So in slow response, basically it rise slowly, while in fast response it rise suddenly and then remains constant. So this is the difference between slow step response and fast step response. This is the poor response, while this is one is the good response. Now we'll see some frequency domain parameters. So the first one is low pass filter, as this is the low frequency which is pass, and then this part is the transition mode, and here this part is not pass. So this is the low pass filter, and here the reverse of low pass filter is the high pass filter. Here the low frequency doesn't pass, while the high frequency does pass. So this is the high pass filter. So now here this one is the band pass filter, because here the specific part of frequency is pass while the other remains not pass. So this is the band pass filter, and this one, the reverse of band pass filter, is the band stop filter, which is like this one. Here the specific part of frequency doesn't pass, while the remaining part will be passed. So this is the band stop filter. Thank you for today's lecture.